Welcome, everyone. Before I introduce our presenters for this session, I have a couple of housekeeping items. After this session, we're going to have a long break. It's going to be 90 minutes. So please stop by the expo hall for lunch. And then after lunch, reminder, the keynotes are going to be kicking off at 2 o'clock. So please join those. And the keynotes are in Salon 5 and 6. Okay, let's get started. So we have two presenters today from ID.me, is that? Okay. Oh, sorry, one second. Their names are Vesko Peklavinov and Ryan Heinrich. And I will let them come up on stage and give more of a full introduction of themselves.
Okay, that's okay. Thank you for that lovely introduction, May. Appreciate it. Welcome to SASE Lessons from the Trenches, Benefits and Pitfalls from Going All In on SASE. I'm Ryan Heinrich. I'm a senior security engineer at ID.me, responsible for network security, custom tooling, and automation.
And I'm Vesko Peklavinov. I run the security engineering team. The team is responsible for designing, building, operating, and automating all the security tooling in the company. And we know we're between you and lunch, so hopefully it's worth it. So who's ID.me? ID.me is an identity verification company and a digital wallet. A little bit like PayPal, but for identity documents. Anything you can carry in theory in your physical wallet that we can verify legally, you can onboard in a digital wallet and use it with anybody that would trust us that we verified it. Again, similar to PayPal. It's used heavily across state, local, federal government. We're credited of preventing a significant amount of fraudulent payments for the public sector. And some customers see a significant increase in pass rates when verifying identity. There was a case with Puerto Rico verifying citizens for access to government benefits, and we managed to double the verification rate to more than 80%. Before we move on, another housekeeping note is if you have questions, you don't need to hold until the end. Just raise your hand. When we're done talking to a specific slide, then we'll pause and address the question. That way it will be more relevant to whatever we're talking at the moment. So just level setting about SASE. There's the Gartner definition. Our definition is basically my perimeter, somebody else's data center, both the perimeter networking and the security components. All the WAN services, security edge services, basically pushed into somebody else's data center offered back to me as a service. But the basic security capabilities are the same, often technically using the same infrastructure that otherwise we would self-host.
Right, and from my perspective, the goal here was infrastructure scalability with consistent security controls, regardless of where you were coming into the network. So protecting those internal resources, whether you're on a remote device or in an office or on premise. So, and then we were also looking to provide visibility into all that traffic as well.
So this is where we started about 18 months ago.
So this was our previous solution. You can see here that we have remote users coming in from one VPN to multiple different places in cloud environments. You can see there we don't have just one, not two, but 6 different VPNs to access different resources in different environments. And this was an issue because users were always asking us, which VPN do I connect to for this resource, or which one is the staging environment, which one's the dev environment. Required a lot of convoluted documentation and created friction for those end users.
They were all individual, had their own names like pets, and you need to address them by name. You have to know what you're trying to access. Also, all access was over public DNS. So internal users connecting to backend system were still going over public DNS, and a WAF kind of similar to external users, even though they were on VPN at the same time.
Right. And at one point, even prior to this, there were VPN gateways that terminated at the offices themselves. So all of that remote user traffic was traversing not just these cloud environments, but also going through the headquarters, out to the internet, then back into our internal resources. And this just created headaches for everyone.
If you think back to the SASE capabilities on the security side from the previous slide, we had more or less the same capabilities in the pairs of Office firewalls, in the next generation firewalls that we were hosting in our cloud environment, and in the cloud firewall VPN service that we were purchasing separately. So pretty much the same capabilities 3 times at 3 different enforcement points. And the firewalls in the offices were also doing routing.
So what's the problem and how did we get here? IDMe started out with about 100 employees in, I guess, the 2021 timeframe. And we were looking at scaling up to more than 2,500 employees in about 3 to 6 months. And this was to meet the demands with new partnerships and to also just increase the availability of our services to our public-facing customers. And with this came a lot of challenges. So as we can all imagine, there was a lot of administrative overhead. There was a lot of time spent just trying to patch things, maintain things. We had all these different VPNs in different environments. The configurations were inconsistent. The scalability wasn't quite there. That was something that we had to figure out how to address. With all this additional load and all these new members coming in from our public-facing side, how do we not only keep our applications up, but how do we scale our internal infrastructure and secure all of that consistently and maintain visibility into all of that traffic? So we were looking for traffic inspection, consistent security configurations, and infrastructure scalability. We were also trying to address an issue with cost. So not only at the offices did we have these hardware appliances, which those can be exorbitant amounts already, but we're also paying for licenses for these next generation firewalls that are running in our cloud environments. If we're looking at scaling those ourselves horizontally, then we're also looking at additional licensing and cost of running those with throughput, bandwidth, and everything in those environments. And then another thing that we wanted to make sure we maintained was, as I mentioned before, security. We needed consistent security configurations. We needed to be able to make changes quickly, but accurately. And we needed those changes to be reflected accurately and consistently across all of these environments. So we wanted to make one change that would affect both the remote users and the users in the offices without having to worry about inconsistencies.
Go back to the previous slide for some context. So each pair of Office firewalls has a slightly different rule set. And they're based on networking. They're IP-based. They didn't have user identity tied to the rule set.
So just to clarify, you were using next generation
old school firewall rules, routing, and some additional capabilities, but very few of the next-gen capabilities.
Right.
Traffic was egressing direct to internet from those firewalls.
And that was also the challenge of having just a handful of engineers internally wearing multiple hats. You know, you need somebody developing something in one place while keeping the infrastructure running. We can all understand that sometimes those engineers get a little overworked, and so we kind of just played house cleaning, you know, where we could at the time. It was very reactionary to things as they came up.
The cloud firewalls as well, they were mostly not just network-based, but had slightly different rule sets because two, not a pair, but two separate ones were dedicated to a staging environment. Different people that have access to those different applications, so a whole separate rule set. And same thing with the three production ones. The cloud VPN firewall was mainly used by end users that needed access to internal resources, but through the front door, not engineers. So again, different set of people, different set of the rules, which goes back to the administrative overhead, the complexity, and the cost, because that's basically three sets of next generation firewalls, three different places. So, requirements for the new solution. We decided we had to overhaul this, come up with something completely new, almost rebuild it from the ground. So we started with this is an initial set of requirements. Cost, obviously, because that was just a necessary waste of resources. We wanted to retire both the Office and the cloud firewalls since they were replicating functionality and was something that could be managed by somebody else, somewhere else. We wanted to move traffic from going over public internet and using external DNS to an internal network, so we can control better access to resources. We also wanted to connect the different cloud environments. What we were showing previously is one set of staging and production environments, but at the same time we had started building another one with a different cloud provider. So connecting AWS, GCP, the remote users working from home, and the offices was key to the new solution as well. Administrative overhead with the sets of policies spread everywhere. That's what's behind centralizing security controls. Basically, a single set of policies across all users, and policy based on identity and what you explicitly authorize to access, but managed in one place, not in 7, 8 different places. Of course, user experience users were not just not terribly happy, but also had like day-to-day usability issues addressing the 6 different VPNs on their own. Routing in the offices was adding complexity, especially for troubleshooting network problems, not even getting to the security stack, between the switching stack in the offices and routing. Bottom line is we had to rebuild the whole perimeter as quickly as possible without impact to users and save cost.
So some of the alternatives that we considered were, okay, let's scale these next-gen firewalls programmatically. That's specifically focused on those in the cloud environment. But we quickly learned that there was a lot of R&D that went into that. that the solution was not quite going to come in the time frame that we really needed it, because there was inconsistent documentation for the products that we were using. We were constantly having to troubleshoot those inconsistencies and then discovering that, oh, well, it was just a bug under the hood. And then that would take time for the vendor to then go figure out what that issue was, maintain the code, wait for them to push out an update. So we quickly realized that that was not going to be a feasible solution, at least in that time frame. Then we also looked at a zero trust access browser that was plugin based, and an internet-facing identity native access proxy. These were open source tools. One thing we kind of wanted to avoid there was a lack of support, because when you run into issues, especially around networking, you can't wait for a community or somebody else to figure out what those issues are when resources are down or inaccessible. That's just unacceptable for an application, especially if you're shooting for that 99% availability.
For the Zero Trust browser plugin, we did look at commercial solutions as well. They worked well for browser-based use cases, but they didn't work for more traditional networking use cases, monitoring traffic outside the browser. We're an engineering company, so IDs and code development and pushing back code is a huge part of what we do. That whole set we would still have to cover with the existing tooling. So the opportunity to reduce cost to smaller, additional layer of tooling to manage, and still gaps in the requirements that we need to address. There are also issues that even though zero trust plugins are still identity based, they can be tied to specific assumptions of whose identity you use. So we were losing the continuous context evaluation because the identity, the solution we were using in-house was not tightly integrated enough with the browser plugins. It didn't have the ability to support the continuous context assessment. So unless we extended the rebuild even further across the whole security stack and make it a multi-year endeavor, that was a significant restriction. We looked whether enterprise browser with security kind of baked into the browser by design and pairing that with EDR would allow us to cover all the requirements. So browser security done by the enterprise browser, including some of the SASE capabilities like DLP within the browser, URL filtering, malware detection, things like that. And then if we can cover with EDR everything else, so network traffic outside the browser. But in order for that to work effectively, we needed to move IDs most likely to app virtualization or a cloud ID. The EDR is not that well targeted towards user traffic and, let's say, data leakage prevention via ID, via other channels. It's very specific towards detection and response of external threats. So that had some gaps. We considered whether we should buy separately a best-of-breed zero trust network access or basically all the security perimeter capabilities from one vendor, and then SD-WAN and all the networking capabilities from another vendor. And for the sake of both time, cost, and ability to manage the whole solution from a single pane of glass, we decided that we prefer a single vendor solution, fully integrated, that we can manage as a single pane of glass. So that brings us to what we ended up with.
So, excuse me, this is our current solution. you can see that there is only one edge for us to secure. All of the traffic, whether you're a remote user or you are in the call center, your traffic is getting piped up into our cloud provider, the SASE provider's network. So under the hood there, they're handling the infrastructure, the scaling. It gives us one central place to maintain security configurations. And what we also added in here was this section to the right where you can see there's a cloud router, which allowed us to get into our resources internally instead of having to access them through the same public access path that our members were using. We're now going internally. We're handling things with like BGP. I should also note that these are also all IPsec tunnels, VPNs everywhere, so data in transit's protected, and we have traffic inspection and visibility into everything that's going into our internal resources. So this was something we definitely did not have before. Everything was disparate, going different ways, and like we mentioned earlier, inconsistent configurations. Here, we make one change. It's reflected for all of the end users that are trying to access these internal resources. This is a security vendor solution that we are using.
And the building part is piecing together pieces, so it's not just the SASE part is a single vendor. That tunnels into a cloud router, which is a software router, and then that builds a managed circuit into the cloud providers, AWS, GCP, any other that.
And that's essentially a cloud agnostic circuit then. You just put in the IP gateway, the configurations for BGP, all the IPsec information, it spins it up and handles all the routing for you.
So it's supposed to be vendor independent, but because of the three sets that we discussed of next generation firewalls previously and the cloud VPN already being Palo Alto, that was kind of the path of least resistance, centralizing everything on their single solution.
So in the chart you list it's secure service edge, so not SASE, right? So you drop the securing components for the cloud provider?
No, that's the SD-WAN routers that are below. That was the first step. We replaced the next generation firewalls in the offices with pairs of SD-WAN routers. Those tunnel into the secure service edge. That tunnels into the cloud router, and then the managed circuits into the cloud providers. What you see as members, that's what we call members of the public that use IDME for identity verification. They're not customers. It can be literally right now any US citizen above 18. Everything moves from external DNS to internal DNS. So the SD-WAN routers and the secure service edge serves DNS to the users. Policies are based only on internal networking, internal IPs. And on the WAF, we removed all the external facing rules outside of some left for failover. We'll talk about in a minute.
And so you can see here that those firewalls that were in the cloud environments are no longer there. So we're not terminating our gateways directly in those cloud environments anymore. So they're just routing into them across these IPsec tunnels. So no longer having to maintain those.
After adding some of the next generation capabilities, we're in the process currently of enforcing always on VPN, so users don't need to know anything about VPN. They don't need to know a name, they don't need to know what they need to connect. They just connect and they go through all the security controls that we expect them to.
So that means that they got to go through this mechanism. If they just want to go to the internet and browse Wikipedia, they still got to go through this,
Yep, they still have to go because we still want to enforce security controls. This is no longer just a VPN. All the security controls are in somebody else's data center, so we need to route them through that data center, or actually series of many data centers.
And it's not necessarily reflected here, but their internet traffic is not going through these cloud environments. The internet traffic is just going through the SASE provider and then out to the public. But for internal DNS resolution or that SSH traffic, access to those internal applications, that is taking that internal private route. And one of the things, features that we got out of this SASE provider, which we'll talk about on the next slide, is identity-based access controls that allowed us to gate who had access to what. So,
in addition, if you're in the office, we can detect that you're in a not necessarily trusted location, but pre-verified location, so you don't need to tunnel anywhere, because the SD-WAN routers already do the tunneling for you. So there you don't need to do anything. Yeah.
Two questions about the endpoint devices. Do you guys have an EDR, and then were you allowing BYOD?
We do have EDR, and we allow BYOD as well, managed devices. And at some point, we may deploy the same type of a solution on the managed devices as well, but so far, it's been only MDM. Moving on. Some of the benefits that we were able to reap migrating to the solution that we were discussing. Overall cost reduction was more than 50% for perimeter networking and security compared to what we had before. Much simpler user experience for end users. Yeah, there's still room for improvement.
well, with that migration, there's certain things that you have to consider about downtime while you're making the migration, educating the end users about the new access patterns, getting them used to these new ways of using their devices and how to connect where. So there are still some complaints. I mean, that's expected with anything you're trying to improve. But there were also some hiccups along the way that we'll discuss on the next slide as well. But some of those great benefits that we got is that traffic is inspected at the closest POP, so where it's going into our SASE environment, before it even makes it into our infrastructure, all that traffic is inspected. All of those features that come with those next generation firewalls, SSL decryption, SSL decryption and DNS security, those features are being handled right there before it ever even gets towards the cloud environments. Not to mention that data in transit is now all protected. We're using VPN tunnels essentially everywhere. And there's a single control plane. I know that's kind of an overused term, but we have that single pane of glass, really, to see activity pretty much anywhere on our network now. So whether it's on a remote device or if it's at the office, we have one dashboard or one platform where we can see what's going on with the remote users, what's going on at the offices. We can make those configuration changes all right there in that central pane of glass also. And that's not just the security changes, that's also infrastructure. On top of that, we have this dynamic network provisioning. We have policy-based forwarding that we can do, which wasn't necessarily possible in the previous iteration. Infrastructure changes sometimes would touch those public-facing applications and had the potential to bring those down. But now we can make these changes on the fly. We can do neat things with routing internally or spin up internal resources now that we have this internal path into these environments. We have a single set of identity-based security controls and policies for all users. What we mentioned earlier, this is now no longer location-based access controls, it's user identity based. So based on our identity provider, we can say this person's an engineer, they should have access into these internal resources or these specific applications. We can get very granular with it. We can also apply those same rules to web-bound traffic, to data filtering policies, DLP, and it gives us all of that with just a few clicks of a button. Whereas these configuration changes would have taken several minutes, which add up after a while, and would typically be inconsistent because you're managing all these firewalls. It's just a couple clicks of a button. And then those policies are rolled out consistently for every environment. All this user traffic, as we mentioned, is now able to route internally. So we have that separation from the public internet with our corporate network internally. And we're no longer pushing all of that internet-bound traffic through our headquarters. When we had those firewalls terminating there with the gateways at the headquarters, it was unnecessary to be forcing all that additional bandwidth and throughput through the headquarters, causing more issues. I'll also add that IT likes us a little bit more because in the offices, they no longer have to worry about who's sitting where. They like to play musical chairs in our call center. And just anecdotally, it can get frustrating because then if they're on a different network or they're connecting somewhere else, they now have that implicit trust of that network. So they inherit whatever access that network had with that previous solution. What we have here, however, is the identity-based controls. Doesn't matter where you go. Even if you're at home, if you come in the office, you're gonna have that exact same end-user experience. You're gonna have access to the same internal resources, and you're gonna have the exact same browsing experience to the internet as well.
What we had originally was a VPN that was optional. You connect to it only when you need to access specific internal resources, which made it a challenge to enforce internet-based security controls. So moving to this solution allowed us also to layer on top consistent URL filtering, data protection, other things like that. So that goes back to some of the happier users because no user has ever been happy about URL filtering and controls. There were some challenges just onboarding users to that, building allow lists. Generally, we take the block by default allow approach. So that requires building pretty consistent sets of allow lists.
Well, one cool feature that came along with that specifically was also the ability to present the end user with an authentication page if they needed access to a resource that they inherently did not have. And that could get approved by the manager. And they can just click to continue, and the manager then approves it. And now they have a temporary access to whatever those resources are. And those are limits that we can set ourselves. That session ends, they have to authenticate, get that approval all over again to access those resources. So.
The dynamic network provisioning, that's not a SASE feature. It's a feature of the solution as a whole, but this is based on the cloud router and having it fully managed by Terraform. So with the same GitOps Terraform model, we can add new network connections, both between the cloud router and the IIS environments, or between the SASE service and the cloud router.
In the back.
Just to clarify, are you using a separate SD-WAN provider?
No, same one.
It's all the same.
Yep. But SD-WAN tunnels into the secure service edge, which then tunnels into the software cloud router. And the cloud router and the integration with it is managed completely by Terraform. Yep, there was a question there.
Yeah, so you actually brought up a point that is a concern for me. When you're sitting in a coffee shop somewhere, you talk about visibility into the infrastructure and the network architecture. How are you guys handling the latency when you've got everybody sitting everywhere? What have you heard from end users on that?
So So we'll talk a bit more in details on the next slide. We do get better monitoring. You can get hop-by-hop network monitoring and a score for digital user experience. But latency is still a challenge, and there are other challenges that are exacerbated by this design.
However, I would like to point out that latency is not as big of an issue as it was previously, because geographically, wherever you were coming back into the same regions in whatever cloud environment. However, with this solution, you have the option to choose regions all over the US, and there's specific regions that are dedicated as global ports that come in that are the first hop into the network. And these are all riding essentially a Google backbone, so it's very high throughput. Latency is a lot lower, so there's a much better user experience overall. There may be a few that complain, but those are the ones that are abroad, and we typically don't operate that way anyway. So for all the US-based activity, those latency complaints essentially went away.
As an engineering team that also operates the solutions, we have an on-call rotation. And what we had previously was the network security take a good chunk of effort during an on-call rotation, because we're managing 6 separate, more than 6 when you include office firewalls, 10 or 11 different rule sets. Changes took longer, and there were more changes across the board. A user traveling outside of the States, by default we allow only traffic within the States. A user traveling outside required multiple implementations to change a policy. Additional changes like that overall took, I would say, maybe a third of the effort for an on-call rotation, whereas now it's mostly negligible. There are occasional changes, but because they're no longer IP-based mostly, it's the identity-based, rule sets don't change as much. The most changes that we get are things like either, again, users traveling or adding a site to allow lists, either to exclude from TLS decryption or allow through URL filtering lists.
One of the things that I like about it is that we no longer have to maintain the firewalls ourselves, the patching, the upgrades, worrying about new what are they called? Worrying about new features being rolled out that now break things. So we don't have to handle that anymore. I don't have to stay up late at night worrying about whether or not the infrastructure is going to fail over to the correct firewall, redirecting routes to the other one. That all is handled under the hood now. They're upgraded. We typically don't see it, and somebody else is doing it all for us. So we can focus on that custom tooling and the automation instead of worrying about doing some of that sysadmin work of just maintaining updates. So huge plus for me.
In the new architecture diagram, we had 3 branch offices down there. In that location, there was a hardware SD-WAN device.
Yep, a pair.
That connects to the software router that gets to the
That connects first to the secure service edge. Basically, the closest POP where security policy is evaluated, and then the cloud router.
And the question comes is, one of the debate topics is, does that make it so much faster than the guy or woman in the Starbucks that doesn't have the SD-WAN hardware device making a decision for them? Is it that much of a difference?
There is a significant performance improvement most of the time. But some of the time there are challenges with it, which is what we'll talk exactly about on this slide. So we were talking about benefits. It's not all roses. What we'll talk about now are not necessarily bad things. They're things to consider and challenges that we faced along the way. So we made a conscious decision to put all of our eggs in one basket. Less baskets to carry. Somebody else carries the baskets mostly outside of security policy. But cloud services don't fail. 100% availability. So we had to build on our own redundancy against failure of the SASE service provider. We still maintain a single cloud-hosted firewall and VPN that mimics the rule set of the SASE service. And there are two ways to access it. One is just as another gateway for the SASE service. So if the service is unavailable, that should be opaque to users that should fail over to that gateway. But if for some reason that doesn't work, they can address it again by name as a separate portal as well. That's still something that we need to maintain. But now that's fully terraformed, managed as code. There is still the possibility that if we went with two separate best-of-breed solutions, the initial higher migration effort may have ended up paying off later. We never explored that hypothesis. So that's something to consider. We can't argue either way. We consciously decided to go with an all-in solution for the sake of time, cost, migration efforts. What that also leads to is an overlap of responsibilities between us and IT for office networking. Because SD-WAN is part of a fully integrated solution, can't separate the two. Now we're partially responsible for office networking as well, including troubleshooting. We spoke about tunneling from the SD-WAN routers and users at home into the SASE service and then cloud routers. That's basically VPN tunnels everywhere, right? So initially, when we first released the new solution, it took us some time until we iron out issues around tunnel reliability. What happens when a tunnel drops down for a few seconds because packets are lost, the keep alive packets got lost, now the tunnel dropped, things like that. There, you hinted at that, also the questions from the gentleman over there around user problems and latency. There's the underlying issue of the networking underlay that's now invisible to us. We push all the traffic into the closest POP of the service provider, but still between us and that POP, we have no control over the underlay. We only have the VPN overlay, so we have little visibility in the underlay. We had a case where a Florida internet exchange was congested. We would see around 8:45 in the morning, turnaround time for all users spike up. And that would stay consistently, and after 5:45, go back down. So we were troubleshooting SD-WAN issues, the networking stack in the office. We were troubleshooting with the vendor, the SASE service, and the infrastructure there, doing packet inspection, monitoring, and so on, until eventually we realized that it's just congestion in that location. All network service providers, cloud service providers were peering there, and once we realized that it took less than an hour for the ISP to route around it, and we had no longer issues. The ISP was unable to detect the congestion automatically. We had to troubleshoot it, but the troubleshooting was not straightforward. Versus the internet is built to route around issues like that. Sending users straight to the internet no longer has that issue. We also had to maintain, for, again, resiliency purposes, the ability to send user traffic from the offices direct to the internet in case tunnels go down for whatever reason. And we're unable to automatically recover them. We can still send them there, and they can still go through the front door, through the WAF, as if they're external users. The identification of users in the offices was not straightforward to build either. That required additional engineering efforts. And the last thing we wanted to talk about, but we're running out of time, is what we would like to see in the future, beyond the current solution. Basically decoupling security from networking. We've been talking about deperimeterization since the Jericho Forum more than 15 years ago, but we still do policy evaluation in that closest POP, somebody else's POP. Ideal scenario would be to do not just policy enforcement, but evaluation on the user device as well. But we haven't been able to get there yet. We're looking at options to start POCing those type of solutions as a next step of the evolution.
Yep. So this was, I guess we could call it more of a stepping stone to the end, the solution that we're looking for at the end, just moving everything to the user device. Now that we have the infrastructure there, maybe we can start getting rid of some of that stuff now too. So.
Do we have time for more questions, or should we keep them offline? There.
There's a lunch and learn that is happening in this room, so I invite you guys to, if you have questions, do you guys mind like maybe taking them outside?
No, not at
Yeah,
all.
we can do that.
That's
So
fine. Of course.
find us outside.
Literally getting text right now saying, how's it going?
Yep.
Right. Thanks, everybody. Appreciate y'all coming out.